Hello everyone, so we're going to start a new unit. This is the trigonometric function unit. We're going to start with the review of angles in radian measure, or basically dealing with angles. Alright, so first the definition of a radian measure is 1 radian is the measure of the central angle. So this is the central angle right here, the central angle in a given circle, where the arc length, this is the arc length right here, BA is called the arc length. If this length is equal to the radius, okay, the length of the radius, then you will have yourself 1 radian measure. Now if you take this and take this arc length BA and map it over and over and over and over, you notice that there will be just little more than 6 radian will be there. And then we're going to go through this part and to show you what is the actual relationship between that and the actual degrees. So we do know that the circumference of the circle is 2 pi r, the radius is 1. The radius is 1, and if it is 1, so what will happen is that you will get the circumference will be 2 pi the measure. That means the arc length will be 2 pi, and we know that in terms of the degrees, the total angle in a circle is 360 degrees. That's a full revolution going from A coming back all the way again to A. That would be 360 degrees. So we can actually now write the relationship between the radian measures, and in this case will be pi will be equal to 180 degrees. This is the very basic radian degree relationship, that a pi radian, so let me go ahead and rewrite that. So pi radians equal to 180 degrees. All right, now pi is actually an irrational number, so it's just a regular set of numbers, irrational numbers, but it is, remember that the decimal expansion of that is non-repeating and non-terminating. So there is a key on your calculator called pi. Now I would suggest against using 3.14, because 3.14 is not pi, it's approximation pi, and is actually a very bad approximation. So use pi key on your calculator to do any of the calculations. So let's go through a couple of examples. We're going to convert degrees to radians and vice versa. So remember, just remember again, pi is equal to 180 degrees. Pi radians equal to 180 degrees. So here we're going to go through, so 30 degrees, we want to basically we want to use the ratio of pi and degrees in order to come up with the unit conversion. That's what that is really. So we want to get rid of the degrees, so that would be 180 in the denominator, and then pi is on top because pi is equal to 180 degrees. So now we can change, and then we go ahead and we can actually make it exact. This would be pi over 6, and sure enough, that's pi over 6 radians. We call it rad. Okay, now let's go to example B. Example B is very straightforward. When you see pi, you replace it with 180 degrees, and that is simple as that. So in here it will be 2 times 180 degrees divided by 3. Okay, that's as simple as that, and then you go ahead and do the math on that one and figure out what that is, and that turns out to be 120 degrees. Okay, simple as that. There's no fancy way of doing this. If it turns out that the values are not exact, now notice that I have given you the exact values. This is the exact angle in terms of the radians, but you could really take out your calculator, go ahead to your calculator, and basically if you want to find out what the exact value of pi over 6 is, sorry, the decimal expansion, you just go pi divided by 6, and here it is. That's you're looking at 0.523598. Okay, so basically that's what that is. 0.5235, 0.52359 8. and that's basically approximation again. Okay, that is the measure of 30 degrees in terms of radians. That is basically it. So a couple of important concepts or things to remember. Number one is that if we have pi equals to 180 then degrees, then we know that 2 pi, a 4 circle, the angle will be 360 degrees. And any other partition of the degree angles will be the partition of the pi, okay? And then we're going to go through and find out. So and the other part of it is this. This is only one full rotation. One full rotation, okay? But if it turns out that you go around the circle twice, let's suppose you go around 2 rotations, then what you will get is 4 pi, which is equal to 720 degrees. And that is basically the concept that I need you to pay attention to. It's all relative, obviously. If you go a quarter of a turn, it would be 2 pi over 4, which is equal to 2 pi, which is equal to pi over 2, which is equal to 90 degrees. Okay, simple as that. So it all depends on that. The next important information you need to remember is the quadrants. Okay, so the quadrants, remember quadrant 1, 2, and 3, 4. So you're starting with the counterclockwise. You're going from here to there. So it's basically quadrant 1, quadrant 2, 3, and 4. And these are the domain of theta. Okay, so this is actually theta, the angle measure that we're going to talk about, or alpha, or whatever, beta, whatever that you're going to call that. But the angles for quadrant 1, which was between 0 degrees and 90 degrees, and so forth and so on. And I could have just put in there, just as an example, a radians measure 0 theta, that's pi over 2. Okay, that's in terms of radians, and you can redo all of them as well. And basically that is it. All right, so make sure that you still remember this, because we're going to use these and degree measure extensively. All right.